Hi Bobcats. In this video we're going to take a closer look at polar covalent bonding and some of the notation that goes with it. We will see how to classify a bond as being a pure covalent, a polar covalent, or an ionic bond. And we'll use the appropriate notation to indicate that a bond is polar. There are a couple different variations of that are commonly used. And then we'll also look at an example to show how to compare two bonds and say which one of these bonds is more polar and which one is less polar. One more time, let's take a look at this concept of a bonding continuum. We can have a pure covalent bonding where electrons are shared evenly, polar covalent bonding where electrons are unevenly shared, spending more time around one atom than the other, and ionic bonding where electrons are actually transferred. So really what we're focusing on right here in this video is this part of our bonding continuum where the two atoms involved in the bond have a difference in electronegativity, and so that makes them unevenly share the electrons, creating a polar covalent bond. So how do you identify that a particular bond is a polar bond? Well, let's real quickly review how we determine ionic versus covalent. We've been saying ever since we studied nomenclature that ionic is going to be a metal plus a nonmetal, and covalent is going to be a nonmetal plus another nonmetal. Well, now we're going to break that down into pure covalent and polar covalent. A pure covalent bond will happen whenever we have the same nonmetal bonded to itself, with the one exception to that being carbon-hydrogen. The carbon-hydrogen bond, even though they're two different nonmetals, it's essentially a pure nonpolar covalent bond. So for a polar covalent bond, what we're looking at is having two different nonmetals bonded to each other. So for instance, carbon bonded to carbon would be a pure covalent bond, but carbon bonded to oxygen would be a polar covalent bond. Once we've decided that we have two different nonmetals bonded to each other, we need to be aware of which side is going to be the partially positive side and which side is going to be the partially negative side. The partially negative side is going to be the one that has a bigger value for the electronegativity, and the partially positive side is going to be the side that has a smaller value of electronegativity. For this example, where we're going to label these polar bonds with partial charges, we need to figure out which one of these two atoms will be the partially negative one and which one will be the partially positive one. Also, when we go to label them, the symbol we're going to use for a partial charge is the lowercase Greek letter delta, which looks almost like a musical note. And then we're going to put a plus or a minus to indicate partially positive or partially negative. So if we think back to electronegativity, it's a periodic property, and if this is a rough sketch of the periodic table for electronegativity, the biggest values of electronegativity are found in that upper right corner. That's where they are big. And so if we're looking at these on the table, carbon is about here, roughly speaking, oxygen is to its right, and then fluorine is further to the right. So the biggest electronegativity out of these three elements will be fluorine, and carbon will be the smallest one. So when we're looking at, say, the carbon-oxygen bond, oxygen's a bigger electronegativity, so it will be labeled partially negative because the bigger electronegativity atom will be the partially negative one, and then the smaller electronegativity atom will be the carbon, and so it'll be the partially positive one. When we're looking at carbon versus fluorine, since fluorine is the bigger electronegativity, it'll have the partial negative, and carbon will have the partial positive. There's one other notation that will sometimes get used. We're going to draw an arrow that shows the direction that the electrons get pushed or pulled. They get pulled towards the more electronegative element, and so we would draw, say, an arrow to the right like this. It's showing where the electrons get pulled, and then on the back end of the arrow we're going to put a little tick mark that makes it look like a plus on the back end of the arrow, and that's where the partially positive end is. If we were to draw that for the CF bond, we draw an arrow still in that same direction from the partial positive to the partial negative side, and we'll put that little tick mark at the back to indicate the positive side. Typically, you would use one of these notations, the deltas or the arrow, but not both. To answer the question of which one of these bonds is more polar, we need to consider the difference in electronegativity of the two atoms that are involved in the bond. We could do this by looking up the numbers, or we can probably do this just by thinking about the periodic trend for electronegativity. If you look at the periodic table, carbon is farthest to the left, and then after carbon comes nitrogen, and then there's oxygen, and then fluorine is right next to oxygen. The electronegativities get bigger as we go to the right. So fluorine has the biggest value, oxygen's in the middle, and carbon is the smallest. So if we were to subtract those numbers, the bigger difference would be between carbon and fluorine, and then there would be a smaller difference between carbon and oxygen. So the bigger the electronegativity difference, the more polar the bond is. So CF is more polar than CO. CO still is quite a polar bond. If you don't like that argument, we can go and look at the numbers. Fluorine is 4.0. Oxygen is 3.5, and carbon is 2.5. So if we were to subtract fluorine's 4.0 minus carbon's 2.5, we would end up with an electronegativity difference here of 1.5 between carbon and fluorine. And if we do that subtraction for oxygen minus carbon, 3.5 minus 2.5, we're going to have a 1.0 for the difference in those two. So that also aligns with the CF bond being more polar than the CO bond. Just keep in mind that a bigger difference in electronegativity is going to mean a more polar bond. So we looked at how you classify a bond as pure covalent, polar covalent, or ionic. Ionic is a metal plus a nonmetal. Pure covalent is mostly the same two nonmetals bonded to each other, but we're also going to consider carbon-hydrogen to be a pure covalent bond, and then a polar covalent bond will be between two different nonmetals. And let's see, the notation that we looked at was we can use partially positive and partially negative on the ends of the molecules, or on the ends of the bond, to indicate where the positive or negative side is. We can also draw an arrow that shows the direction the electrons are getting pulled with a little tick mark back on the positive end. And then to rank from the least polar to the most polar, we're looking at the smallest to the biggest difference in electronegativity between the two elements that are involved in the bond.